A bricklayer builds a triangular wall with layers of bricks as shown. If there are 50 layers of bricks, how many bricks did the bricklayer use? We did this already last time with however many it was, 18 or 20 layers. And in reality, it's just the counting numbers. 1 plus 2 plus 3, on to 50. The formula for an arithmetic series is the sum of n numbers equals the sum of n numbers, n divided by 2, the first number in that sequence added to the last number in that sequence. The sum for this particular problem, the sum of 50 numbers is going to be 50 and 50 divided by 2. The first number in the sequence, there's one brick at the bottom plus 50 at the top. The sum of 50 25 times 51. The sum of 50 1,000 something, you said. Get a calculator. 1,275. That is it. Moving on to the lesson for today. I just want to get going with this. Lesson 8C, geometric sequence. What is a geometric sequence? For the last week, we did arithmetic series and sequences. Last week it was all about adding a constant amount or subtracting a constant amount. In this lesson, we are multiplying by a constant. In a geometric sequence is a sequence of numbers where each term after the first term is found by multiplying the previous one by a fixed non-zero number called the common ratio. So this is how math builds on itself. It is really the exponential function written in a different way. What's the equation of an exponential function? We did chapter 6 barely. Y equals what? Loud. What's the equation of an exponential function? The equation of an exponential function is y equals a times b to the power of x, where a was the initial amount, b is what you're doing to that initial amount, and that is an exponential function. In the formula for a geometric sequence is really the same, except they change, the y will change to something else. The y will change to a sub n. A will become a sub 1. A sub 1. And then b will become the common ratio. What do you think we're going to use for the ratio? Common ratio should be r. And then x will become, since we would already have used a1, well, no, I'll tell you what it's not going to be x, it's going to be n minus 1. But they are very similar. Y is a sub n equal. A is a sub 1. B is r. X is n minus 1. And now that we do have the formula, we just got to plug in numbers for them. You will need to definitely know A1. What is A1? And you need to know what the R is. All right. So an equals a1 times rn to the power n minus 1. And we'll do problem 1. A virus starts with 100 people infected and it doubles every day after that. What would be the formula that models the situation or the sequence? So in 4 years ago, I still do remember, there was that pandemic. Some people got really, it's pretty bad. And let's say that in that pandemic there was it actually did happen. There were people that were in a cruise ship that were quarantined and they were not let out for a long time. Imagine being inside of a cruise ship for that long. In any case, say that this happened, no? A virus starts with 100 people infected. So then imagine there was a cruise ship and there were 100 people in that ship. And then imagine that was before that pandemic. Imagine that nobody knew. So if you had 100 people that were infected in a ship, cruise ship, and then they just went home back to wherever their hometown was, and then this happened. It's like a movie. The next day, how many people were infected if that is true? 200 people. The second day, how many people were infected by then? 400 people. Third day, how many people were infected? 800. Fourth day, how many people were infected? 1,600. Fifth day, how many people were infected? 3,200. Sixth day, 6,400. Seventh day, 1 week, 12,800 people. You see how, like, before you know it, it's just, that's how it's exponential. So a virus starts with 100 people, A1, and then it doubles every day. This is so easy. This is easier than what we did last week. A sub n equals a sub 1 times rn minus 1. A sub n equals, a sub 1 is the amount of people that are infected day 1, 100, I guess A1 is 100. R is that it doubles, n minus 1. How would we know if this is truly what's happening in real life? A1, 1, plug in 1. I'm saying this is the equation, or the formula. A1 better be 100. What is 1 minus 1? What is 1 minus 1? 0. 0. You're already thinking the next number. 2 to the 0 power is? 1 minus 1 is 0. 2 to the 0 power is 1. 1 times 100 is 100. Yeah? Make sense? Let's do the next one. N is 2 for A sub 2. We don't have to be doing this, but I just want to do it. What's 2 take away 1? 2 minus is 1. 2 to the 1 power is 2. 2 times, it's 200. This is working. Yes, this is it. All right. Move. That's the formula. Easy. All right, let's go. Tell whether each sequence is geometric. If it is geometric, find the next 5 terms. Problem 2, you got 3, 6, 12, on. Is this a geometric sequence? How would you know if it is? If to get the next number we multiply by the same number, it is. 3 times what? 6 times 2, 12 times 2, probably, yes it is, yes it is. So, it is, because we are multiplying by that same common ratio. So, 3, 6, 12. What is the next number? 24. What's the next number? 48. What's the next number? 96. What's the next number? 192 is correct. The next number? 384. This is pretty easy, and this is taught in Algebra 1. I know that it was. Let's go to number 3. Is this a geometric sequence? Yes or no? Why is it a yes? We're multiplying by 3 to get the next number in that sequence. So it's a yes. 139. What's the next number? Next number. 81. Next number. 243. Next number. 729. Next number. 2,187. Yes. 6,000. 18,000. And okay. So you see how it's going to get bigger after that. Really big. 1, 2, 3. 2, 3, 4. Let's go. Moving on. Write a rule for this nth term of the sequence. Number 4. A1 is 4 with a common ratio of 2. So easy. This is pretty easy. The formula says a sub n equals a sub 1 times what? R to the power of what? N minus 1. Do we have a 1? Yes. We have R, yes. This is too easy. A sub n equals 4 times 2 to the power of n minus 1. Five. What's the equation for that one if it is geometric? A sub n equals 5 times 3 to the n minus 1 power. Okay, so very easy until it gets kind of hard. Here we go. We'll be done after this one. No, are we? Are we? No, we're not. Okay, we got one after this one. 6. One term of a geometric sequence is a sub 4 equals 12. The common ratio is r equal to 2. Write a rule for the nth term. A sub n equals a sub 1 times it by the common ratio r n minus 1. We do have r. We do have r, and r is 2. But we don't have the A1. Is there a way that we could just kind of figure it out by sequencing it? Yeah, let's see, go like that. So it's saying that A4, this is A4, A3, A2, A1, A5, A4 is 12. We need to get A1. So What's 8.5? 24. 24. So going that way, we're multiplying by 2. And so going to the left, we're going to do what? Divide it. Or we could multiply. Yeah. Well, we are dividing. So what's the next? What should be the number here on the left? 6. Then what's 3 divided by 2? Well, leave it as 3 over 2. But it is 1.5. Okay, so we know that the answer is 3 over 2. Like, it makes sense that it would be, no? Now, what if we didn't want to do it that way and say that it was A100 that they gave you, A100? You are not going to be doing A99, A98, A90. You're not going to, that's too much to do it that way. We already know that the answer is 1.5. But what would be another way of doing it? All right. If they told you that A4 is this, let's use that. A sub 4 equals, we don't know what A1 is. R is 2. N is 4. Take away 1 has to equal to what? A4 is equal to what? It's equal to 12. Now we only have one. We got A1 to solve for. What is 4 minus 1? What is 4 minus 1 here? And what is 2 to the third power? What is 2 to the third power? 8. 8 times A sub 1 is equal to 12. How do I get the A sub 1 by itself? Divide by 8 on both sides here. And now we got A sub 1 is, what is 12 divided by 8? Or we can divide top and bottom by what? 4? 12 divided by 4 is 3. 8 divided by 4 is 2. Wasn't that what we got the other way? So A1 is 3/2 with the R is 2, and just plug it in here, and you're done. Last problem for today. Here we go. Last problem. All right, number 7. Write a rule for the nth term of this geometric sequence. Well, we don't know what A1 is. We don't know what R is. So we got 2 problems. Why don't we try to just do it the way we just kind of did the other one? Why not figure it out like that? Because they're kind of close to each other. A1, A2, A3, A4, A5, on. A2 is 12. A4 is 3. You know that we gotta either multiply or multiply by common ratio, or going backwards. No, I don't know. Can we put some numbers there and see if we can do a sequence where we multiply or divide by some common number? What can be A3? What can be A3? So what would this one be? And this is what? 3/2, no? Isn't it backwards what we just did? Times it by 2. Because if we go that way, times it by 2, going that way, it'll be 3 to 6, 6 to 12, 12 to 24. Yes. So, well. So the equation for this would be what? A sub n, but it always should be going to the right. So A sub n equals what? What's A1? What's A1? 24? And what are we doing to go to get to the next number? we're dividing by 2 or we're timesing it by what? 24 times what, this is what the common ratio is, gives you the next number. What are we doing? We're timesing it by what? 0.5 or a half, yes? So half of 24 is 12, no? So we're timesing it by half. So this R is 1/2, n minus 1. All right, this works. If you want to be lazy, would you do it this way? Is there another formula that would work for this sequence that we can create another sequence? If we don't do this, what if we do something else? Would there be another formula? The answer to that is that there is another formula. Here we go. Let me find the other formula. We already know that this works. Let's come up with the other formula. Look, everybody, this is the most difficult part of this one right here. Let's create two equations. One for this one. A sub 2 is equal to, we don't know A1, we don't know R. 2 minus 1 is equal to 12. Okay? Yes, that's not hard. Let's do another one for this one. This one. A sub 4 is equal to, we don't know A sub 1, we don't know R. 4 in for n minus 1 has to equal to what? 3. So we have two equations here. Let's kind of clean them up over here. Let's go over here. So this is going to be A1 R, 2 minus 1 is 1. So it's just A1 R 12. A sub 1 R equal to 12. Here we got A sub 1 R, 4 minus 1 is 3. So we got R3 to the power of 3 equals 3. So we got two equations, two unknowns. What I'm going to do is I'm going to solve for A1 here and then plug in what it is over here. I'm going fast. I just want to get this done with already. So cancel that. A1 is equal to 12 over R. So wherever you see an A1, plug in 12 over R. A1, 12 over R. Okay, in terms of the R's, let's deal with the R's. How many R's are there on top of this fraction? How many R's on top? 3. How many R's at the bottom? Where are there more R's? How many more on top compared to the bottom? So it's going to be 12 R squared equal 3. How do I get the R by itself? What should I do the next step? Divide by 12? Yes. So we're going to get R squared equals 3 over 12. Three over 12, if I divide by 3 top and bottom, I'm going to get what? R squared 1/4. Square root it, R is going to equal to what? Anytime you have an equation and you square root both sides, it's going to be a plus and a minus. Square root of 1 is 1, square root of 4 is 2. So we already found the positive one. We already did the positive one. 1/2, positive 1/2. But it's saying that we can also do R is negative 1/2. Let's get that one with the negative 1/2. Here we go. Let me do this one now. And use one of these to find A1. Let me do the A2. A sub 2 equals, we don't know what A1 is. We're saying that R is negative 1/2. N minus 1. Well, I'm using N is 2, so I better use N is 2 here. 2 minus 1 equals 12. Two minus 1. What's 2 minus 1? 1. So I have A sub 1 times negative 1/2 equal to 12. How do I get the A by itself, A1 by itself? I can divide both sides by what? But top and bottom? Divide top and bottom by negative 1/2? But what's a better thing to do? Multiply both the left and the right side by the reciprocal. What's the reciprocal? Negative 2 over 1, or just negative 2? Negative 2 over 1 here, and negative 2. So then we're going to get that negative and negative is positive. Cancel 2 and 2 cancel. A1 is negative 24. A1 is negative 24. And this is going to create a sequence that will match this right here. How do I know? Watch. The equation, when it has a negative, it would be this. A sub n equals A1 is negative 24. R is negative 1/2 to the power of n minus 1. Now let's see. Let's test it. A1 will be A1 will equal to negative 24, negative 1/2. 1, plug in here, 1 minus 1. What's 1 minus 1? 0. Anything to a 0 power is what? 1 times negative 24. This is going to be negative 24. Now let's do A sub 2. A sub 2, negative 24, negative 1/2. N is 2 minus 1. Negative 24. Times it by? What's 2 minus 1? 1. So it's going to be negative 1/2 to the 1/2 power. Negative 1/2. I mean to the 1 power. What's a negative times a negative? What's half of 24? This other sequence works. But the numbers are going to be alternating when these are always positive. This is going to be negative 24. What do you think this is going to be? Negative 6. Positive, this is going to be what? So this A2, A4, A6, A8, those are going to be positive. That's why it fits it. But the other ones will be negatives. That's for the other sequence. He has two sequences that matches it. We are done. That is it for today. It's another way. I don't know what I got there. And we're done. Oh, there's another one.